This table from Standard Plan A is the foundation of the whole system. Every Standard Plan A retrofit must refer back to this table. So it's very important that a table like this be accurate, and that the components that they're using are defined properly in terms of the amount of earthquake resistance that they have. Let's take a look and see how a retrofit would work using this table. So let's assume this house is 1,200 square feet, and it's heavy, which means it's either stucco or it's got plaster inside for the walls, and it's 20 feet is what the plywood bracing must be. So that means each wall on this house must have plywood bracing, or just plywood, that's 20 feet long. Now this right here is the mud sill anchorage. That's the same as bolting hardware. And so what it tells us here is that if we're going to put in 6 UFP10s, if we need to put in UFP10s, we have to have 6 of them. If we're going to use half-inch bolts, we have to have 9 of them. And if we're going to have 5/8 bolts, we have to have 7 of them. What they've anticipated, they said, okay, if there's a certain amount of force that's going to attack the house, and 7 bolts of these 5/8 bolts is going to provide the force that we need. So over here we have what's called framing anchors, or framing clips, and that is the same as the shear transfer tie, which you'll read about elsewhere in the website. And it's the exact same thing. If you're using an L70, you have to put in 17 of these. If you use an H10, you have to use 13 of these. And if you use an L90, you have to use 13 as well. So again, this hardware is set up so if you figure out the amount of force, and then each one of these pieces of hardware provides a counterforce. So again, it's extremely important that these be accurate. The table on the left is found in Standard Plan A, and it tells us the connector capacity, in other words, the capacity of all these pieces of hardware that are in that table. And for example, for the L70 right here, it tells us that it can resist 458 pounds of earthquake force. For the L90, it's 600 pounds of earthquake force. Now let's go ahead and see if that's accurate. So here's our L70. We come over here and we look in the manufacturer's catalog and the test report, and it says it can resist 740, which is quite a bit different than the 458. Now the same thing with the L90. It's telling us here it's 600 pounds per piece of hardware, and right here we have 925. So let's go ahead and see what it says about the other hardware. So now we're looking at the H10 hardware. That's one of the hardwares that was in that table we looked at. And what it says here is it can resist 505 pounds. Now in actuality, in the manufacturer's catalog, there is no such thing as an H10. So we're going to assume they meant either the H10A or the H10AR, as if they're the same. However, if you look at the actual table, the H10AR is 490 pounds. Which is different than the 505, and that the H10A is 590 pounds, quite a bit different than the 505. So this is another inaccuracy in the table. So let's take a look and see how they did with the bolt. Standard Plan A says a half-inch bolt can resist 820 pounds, whereas the actual calculations shows it can resist 1,119 pounds. The same with the 5/8 bolt. It says it can resist 1,170 pounds according to Standard Plan A, and actual calculations so it can resist 1,555 pounds. So you can see the problem here. If it can actually resist 1,555 pounds, that means your bolts are actually a lot stronger than what Standard Plan A says. So if you put in the bolts that Standard Plan A says to put in, you're going to end up putting in too many bolts. Because it's just not accurate. It's just, we're not in touch with reality here. It's the same with the half-inch bolt. So we've seen, up to now, in all cases, the values that are in that table are wrong, and that are the basis of the original table that tells you how many pieces of hardware to put in. So it can really get confusing. How much are you supposed to put in? And what are the other problems with Standard Plan A? We're going to see those in a minute. So Standard Plan A did actually get it right on one piece of hardware, and we're going to look at that one right now. That happens to be the UFP10. This is a UFP10 right here in this image, and what it is this is a piece of hardware that bolts to the side of the mud sill. So you have these bolts right here, and then it bolts into the concrete, and that's done when we don't have any room to put in a regular bolt. Here's an actual photograph of what I'm talking about. So here's the UFP10. Naturally, we couldn't put a bolt coming down in here because this is only like 8 inches between here, and you can't get a drill motor in. So this is what they look like. Now this 1,340 pounds, that is only if it's in Douglas fir. So this right here looks like a piece of pressure-treated Douglas fir, which we see in houses that are built from 1973 on. But these houses that we're retrofitting are usually built before 1973, and they're all made out of redwood. And when they're made out of redwood, we must multiply it times 0.74. So we take that value, the 1,340 pound value that we had in Douglas fir, we multiply that times 0.74, and then we end up with a value of only 991 pounds. Now the reason we use that multiplier is that different species of wood have different abilities to hold nails. And so the softer the wood, the less able it is. And Douglas fir is actually much harder. So when you get a value in a catalog like this that says 1,340 pounds, and you're going into redwood, you must multiply it times 0.74. So, basically every single piece of hardware, every bolt, every framing anchor, everything that they put into that table, they got it wrong.